My name is Mark Jolly Van Bodegraven. I'm the Director of Communications for the University of Delaware's College of Earth, Ocean, and Environment and the Delaware Sea Grant College Program, the two organizations that put on the Ocean Currents lecture series every summer. And I thank you all for joining us for tonight, the third in the series. Tonight, we're doing something a little bit different. We have two speakers who will address related but different aspects of the same topic. We'll get to that in just a minute. Before I introduce our speakers, though, just a couple housekeeping things for everyone. I want to point out to our attendees that the chat is open for you. You can use that to talk with each other or to thank the panelists, put comments of that sort in the chat. But we also have a Q&A feature at the bottom of your screen, which we'd like you to use for questions. So if you have something occur to you, a question you'd like to pose to either presenter at any point during their presentation, go ahead and drop it in the Q&A, and we'll have those waiting there for the end. When they wrap up and when they're done, I'll come back on and go through as many of those questions as we can and ask them to join in or to answer those. So with that kind of detail out of the way, let me introduce our two speakers. First, we have David Kirchman. He retired from the University of Delaware last year as the Maxwell P. and Mildred H. Harrington Professor of Marine Studies. He holds a BA in biology from Lawrence University and an MS and a PhD in environmental engineering with a focus on microbiology, both from Harvard University. Dr. Kirchman is a recipient of UD's Francis Allison Award and is a fellow of the American Society for Microbiology and the Association for the Sciences of Limnology and Oceanography. He's the editor of Microbial Ecology of the Oceans and the author of Processes in Microbial Ecology. And earlier this year, Dr. Kirchman published Dead Zones, the Loss of Oxygen from Rivers, Lakes, Seas, and the Ocean, in which he explains the impacts of dead zones and provides an in-depth history of oxygen loss in water, topics he will be discussing tonight. Our second speaker is Jerry Kauffman. He is the director of the Water Resources Center at UD, one of the 54 National Institutes for Water Resources designated by Congress at land-grant universities in the United States. Dr. Kauffman holds faculty appointments in the Joseph R. Biden Jr. School of Public Policy and Administration and the Departments of Civil and Environmental Engineering and Geography in the College of Earth, Ocean, and Environment. He teaches, researches, and writes about water science and policy, and will be sharing that perspective with us tonight. With that, I'm going to turn it over to Dr. Kirchman.
Okay, let's see if I can get this started. Okay. So, yeah, well, thanks, Mark, for that introduction, and thank everyone for coming up today and showing up or logging in or whatever we are doing now on Zoom. As Mark mentioned, this is a kind of two-part talk. I'm going to introduce some of the science behind this problem that we have in the Delaware River with oxygen. And Jerry's going to follow up and say a bit more about the impacts of low oxygen in the river. In case you have to leave early for whatever reason, let me give you my take-home message. And there's two parts. First, there's some good news. There used to be a dead zone in the Delaware River, but there no longer is. But unfortunately, the bad news is we still have a problem with oxygen being too low in the river, and I'll say why about that in a minute. So as Mark mentioned, my talk is kind of basically taking things I've learned from writing this book, which I hope all of you could understand and read. It's pitched to everyone, just published a few years ago. The book has a good part of a chapter about the Delaware River, but it also has much about dead zones around the world. And fortunately, there are many things we can learn from other habitats to try to solve this problem that we have in the river. And the book has, of course, more space and time to go over some of these problems with low oxygen. In some ways, it's really easy to understand. If organisms, including us, don't get enough oxygen, we die. And so fish kills are the most obvious consequence of oxygen running out in an aquatic habitat, but there are many others. Some more difficult to understand, such as the loss of biological diversity. The odors that come out of dead zones, waters with very low oxygen, are not something that you really want to experience. There are more subtle effects. Organisms become more susceptible to disease and parasites. They don't reproduce as well. And this is illustrated here with this picture from a paper that appeared a couple of years ago of ovaries taken from Atlantic croaker. These ovaries are from fish that have normal amounts of oxygen versus those that were raised in hypoxia, which is very low oxygen concentrations. I'm not going to have much time or enough time to say more about all these impacts and consequences of low oxygen, but I'm going to say a few more words about how low oxygen blocks migration of important fish species. And then Jerry's going to continue on talking about some of the environmental, the economic impacts. So we need a few numbers to understand, how dead is a dead zone. So if your body, any part of your body runs as low as 92% of oxygen, you're in trouble. You may end up in the hospital. The biomedical term for that is hypoxia. It's a term that the ecologists stole to talk about low oxygen, although when they talk about low oxygen, they mean really low oxygen. Mountaineers may know about the death zone, which is especially on Mount Everest, which is about 24,000 feet and higher, where oxygen is about 40% of sea level concentrations. And so in this zone, 24,000 feet and higher, people would die if they didn't have bottled oxygen. In fact, as you probably have heard, many have. The dead zone, that is hypoxia in water, is even lower than that, 25% of fully oxygenated water. But these percentages don't really give a complete story about how low this oxygen really is, because air has much more oxygen, roughly 40%, than water can possibly carry. So when we talk about low oxygen in water, it's really, really low. Now, a better way to talk about oxygen concentrations is milligrams per liter. And fully oxygenated water has roughly 8 milligrams per liter. Colder water has more, hot water has less. At the other extreme, the dead zone, we use that term, at least in the popular media uses that term. Scientists like to talk about hypoxia. That occurs when it's about 2 milligrams per liter or less. Now, there are some organisms like oysters that can actually withstand for short amounts of time these very low concentrations of oxygen. Oysters basically clam up. They shut up and turn off their metabolism, and turn it down as low as they can. They switch over to a form of metabolism that doesn't require oxygen. But eventually they need to breathe, to keep on surviving. They can't exist indefinitely at dead zone levels. Blue crabs, like oysters, also are found in estuaries, and so they're a bit more tolerant of low oxygen, but they too will succumb and die when exposed to sub levels of oxygen. But many more organisms are like bluefish that are sensitive to oxygen even when it drops just a couple milligrams per liter. So the main message here is that even small drops in oxygen, because water can hold so little oxygen to begin with, even small drops in that little amount has big consequences for the organisms that are living there. You don't have to get down to dead zone levels before you have big impacts on the environment. So there's some famous and infamous dead zones. Perhaps you've heard about the Gulf of Mexico. Has a big problem every summer, probably starting right about now, just south of Louisiana. And this red here in the northern Gulf of Mexico is waters that have very low concentrations of oxygen, hypoxia. And that dead zone comes about because of the Mississippi River bringing in all the nutrients from the Corn Belt in the Midwest down to the northern part of the Gulf of Mexico. A bit closer to home, we have the Chesapeake Bay. Again, the red indicates the very low concentrations of oxygen. Those waters have very low concentrations of oxygen. In both the Gulf and the Chesapeake Bay, these waters, as well as in the Baltic Sea, these low oxygen waters are found at the bottom, which is different from what we'll see in a minute for the Delaware River back in the 1940s. Again, big parts of the Chesapeake Bay have very low oxygen concentrations in their bottom waters. It's not as big as the Gulf of Mexico, the hypoxia that we see in the Chesapeake Bay, but it covers a bigger part of the estuary. It has a much bigger impact there. But the biggest of all dead zones is usually said to be the Baltic Sea over in Europe. Baltic Sea, you can see here Sweden, and then on the east coast are the Baltic states, and the north is Finland, and the south is Poland. Again, the red indicates the waters with very low concentrations of oxygen, hypoxia levels. The black is even worse. These waters have basically no measurable amounts of oxygen. They're what we call anoxic. And that brings in a whole nother suite of problems when oxygen basically is gone to zero. And when that happens in seawater, hydrogen sulfide is produced. Hydrogen sulfide smells like rotten gas. If you've ever gone past a salt marsh early in the morning, you can smell kind of whiff of a bit of that hydrogen sulfide. But don't take more than a whiff because it's extremely poisonous. So organisms that, if they're not killed off by the low oxygen, they're going to be killed off by the hydrogen sulfide. So there are a lot more dead zones. In fact, there's at least 500. Some estimates put it as closer to 1,000 around the world. This map was made by Bob Diaz over 10 years ago. And the point he was making is about the increasing numbers of dead zones, that they're increasing. We've probably reached a plateau, if only because we've kind of looked in all the places where we expect a dead zone, especially in Asia and China. There are now more dead zones that are indicated by the black dots in this map. Even though the numbers of dead zones probably have reached a plateau, the size of many of these have increased over time because of the continuous insults that we are inflicting on these water bodies. But we don't have to go very far to Europe or China to find the problem. It's one in our black backyards, at least my backyard here in Lewis. This is a headline from a News Journal article that appeared about 3 weeks ago or so about a fish kill in one of the canals off of Rehoboth Bay. These canals are kind of infamous for having these fish kills. And often the fish kills consist of menhaden. I'm sure other organisms also croaked when the oxygen disappeared in these canals, but menhaden are very melodramatic when they kick the bucket. Because of their swim bladder, they float to the surface and are more easily seen and counted by folks on shore. The folks at the Delaware, the Center for Inland Bays, Marianne Walsh especially, just recently emailed me and mentioned that there are more than, this is not an isolated incident of a fish kill in these canals. They occur roughly a couple every year. It's just only sometimes they make the headlines like this. So it's a problem worldwide, and it's a problem even in our backyard. It's my backyard. But when we come to the Delaware, there's again good news and bad news. The good news is that, to back up, this is a map I like to show in various presentations of the Delaware, state of Delaware, back not quite a decade after it ratified the Constitution. And for those of you who may be in New Jersey, no, you're not in Delaware, you're still in New Jersey. Delaware, of course, is the three counties here in a little bit more vivid colors. Anyway, the good news about the Delaware is that the bay itself, this larger, wider part of the whole estuary, has never had a problem with oxygen. It's very well mixed, and oxygen has always been at high levels because of mixing from the ocean and from the Delaware River. However, it's not the case for up in the river itself, especially south of Philadelphia. And this is where we've had and still have a problem with oxygen. So this is a graph illustrating that problem. And it's an old figure that I took from a paper that appeared, you can see there, over 20 years ago. And it gives milligrams of oxygen per liter versus river mile. And it's just a way of measuring distance along the estuary, with 0 being somewhere way over here, Lewis, and then Philadelphia being roughly 100 miles upstream from from Lewis. And I'm going to concentrate first on 1946, when basically that was really the darkest days in terms of the Delaware River as a habitat. And you can see here is that as we go downstream from Philadelphia, we see this dramatic drop in oxygen concentration, such that just downstream of Philadelphia, the river mile 100, oxygen has gone down to 0, much lower than the dead zone level of 2 milligrams per liter. And they continued to be 0 for nearly 20 river miles. And this dead zone, I'm sure, extended from the top of the water column from the surface down right down to the bottom. So the whole thing was completely lacking in oxygen. We'll get to later the improvement that we see also in this graph, how things have gotten better. But the point here is that back right around World War II and a few years after that, things were pretty bad in the river, especially south of Philadelphia. And there are these great reports of how bad the river was how bad it stunk. And this one report I really like comes from a weekly magazine, Collier's, that started publication in 1888 and shut its last publication was 1957, if I remember correctly. I guess a few other issues came out around 2012, but then it stopped publications for good. Anyway, great magazine, has lots of great fiction by authors that you probably would recognize, great investigative reporting as well, including this article about the state of the Delaware River. And the article begins by saying the Delaware is a slovenly river that has been begging for a bath since the founding fathers met along its banks. As far as pollution is concerned, it could surpass almost any river in the world, where there are fewer, better examples of man's inhumanity to man and to nature. So pretty dramatic beginning to an article, but it's not too much of an exaggeration to say the river was really in bad shape at this point of its history. And the article goes on to talk about various stories about how bad it stank. One story is that as pilots would fly into Philadelphia, supposedly they could smell the river from 5,000 feet. And I think Jerry has some pictures of other impacts of how some of the gases coming out of this part of the river, tarnishing ships and factories and so on. So I'll let him tell you some of those stories. So I mentioned that at the beginning that there's good news and bad news. The bad news, well, I'll get to the bad news. The good news is that things have gotten better, and that's what's illustrated by this graph of oxygen concentrations versus year. These are yearly averages. And it comes from a figure that John Sharp made now over 10 years ago. And then I added the data for the last 10 plus years from the US Geological Survey, monitors oxygen of the river throughout the whole estuary, actually. And so you can see back in the late 19th century, oxygen concentrations are not quite to that 8 milligrams per liter that I mentioned, but that's probably about 100% saturation for that temperature in those conditions. And then as Philadelphia grew, oxygen concentrations dropped and it reached dead zone levels. Actually, back in the 1920s, over 100 years ago, and then it really reached that really dead zone. I don't know, you can be more dead than dead. Anyway, it was really bad right around World War II and the years following that. And then the good news is it started to come back up. Oxygen concentrations came out of that dead zone and today are almost back up to where they should be, at least on a yearly average. I'll say a few more words about that in a minute. That's the bad part of the bad news part of this story. So why did oxygen concentrations go back up? As you can probably guess, we realized, we being society, that it wasn't such a great idea to dump untreated sewage into the river. And there were treatment plants that were built before 1972. And that caused, it was the reason why concentrations of oxygen started to creep back up back in the 60s. But it really took the Clean Water Act of 1972 to basically force cities and provide the means, the financial means to build treatment plants. And it's for that reason that the Delaware River is no longer a dead zone. And it's also the reason for the other few success stories around this country. And there's similar legislation in Europe and elsewhere where the government basically forced cities to build these treatment plants to clean up the sewage before they dumped it into the river. So when I was working on this book, I'm going to return to this graph because this is what I kind of left thought the situation was in the river. I thought, well, we still have some ways to go. There's certainly a lot of other problems facing the Delaware than just oxygen, but I thought we're safely out of the dead zone. We don't have to worry about that anymore. And it was only talking to Jerry that got me to look more closely at the data and to look at and take apart what was happening in each of these years. And so here's the figure I made after I did that. It's a bit complicated figure. I'm going to take some time to walk through it. And so this is daily averages of oxygen at the Ben Franklin Bridge in Philadelphia. And it goes from 1960, you can see here, to the present. And one message is what I've already mentioned is that oxygen concentrations have increased and gotten better over these decades, again, primarily because of the treatment plants that have been put in. But the data also have another message, and that is the bad news part of the talk. And what we see here is that, so again, it's gone above the dead zone level at 2 milligrams per liter, but it's still too many times below these other, especially this 6.5 milligrams per liter standard. That's what oxygen should be for these two seasons in the spring and fall. And those turn out to be critical seasons for the migration of many fish species. And what these data show is that although we're not at dead zone levels anymore, we certainly have a problem with low oxygen in the river. Now, I should say that the standards vary depending on where you are in the estuary and river. And as I kind of alluded to already, it depends on what time of the year. But for these two, spring and fall, roughly, you can see that there are many of these gold and green dots that are below the 6.5 milligram per liter standard that the river should be at for those seasons. So we have a problem with low oxygen in the river still. And you can say, well, who cares about fish or whatever river life in Philadelphia? Who's going to eat anything out of the river at Philadelphia? No one, right? Well, I think you don't want to be near a aquatic habitat where oxygen's so low because of all the other problems associated with it. But when it comes to the life in the river as well as in the ocean, that stretch of very low oxygen concentrations downstream of Philadelphia and around Wilmington has big impacts for how these organisms carry out their life cycle. And in particular, I'm talking about the two poster childs for this message are shad and Atlantic sturgeon. These two fish spend their adult part of their life cycle in the ocean, but they have to migrate upstream and spawn in fresh waters. That usually occurs in the spring. As you may guess, they don't look at a calendar and figure out that they can go when the government says that the oxygen should be high. So what's spring to them may not be spring to us, is what I'm trying to say. Anyway, the point is that they have to go upriver to spawn and complete their life cycle. And they're not going to be able to do that if oxygen is too low right around Philadelphia and downstream from it. And likewise in the fall, after spawning and growing to a certain size, they have to migrate back down the river and complete the rest of their life cycle in the oceans. So I think Jerry's going to say a few more words about the shad fisheries. I'll mention that Atlantic sturgeon is especially endangered. It's on the Federal Endangered Species Act list, and it's very few individuals of this fish species, in part because we still have this oxygen problem. Many other problems that are facing both of these fish species, but the low oxygen is not helping it. So you may be asking, why is there still a problem with oxygen in the Delaware River? We have these really $1 billion spent on these treatment plants all up and down the river. Why hasn't that solved the problem? And to explain that, we have to look a bit more in detail about what the sewage is. And I'm going to oversimplify things and just talk about as if sewage were just organic carbon. And if you think too much about it, I hope you can see that this organic carbon is basically human waste. But that organic carbon also comes with a lot of nitrogen, and especially nitrogen in the form of ammonia. And that's critical that the nitrogen be in that form. So the sewage treatment plants, fortunately, are really good today with removing the organic carbon. But what they don't really touch is the ammonia. So there are, and the reason is that the treatment plants are built to the specifications set by the law, that they have to remove the organic carbon, but there's no regulations now on how much ammonium they release. And that's a problem because there are bacteria, specialized bacteria, that just love ammonium. They use it as a food source. It's their Big Mac. It's their whatever. It's their candy. They use it as an energy source. More scientifically speaking, they oxidize it using oxygen as an electron acceptor. And in the process, they drive oxygen concentration to the levels that we have today that are too low for the rest of the biota in the river. It may not be down to dead zone levels as illustrated by this picture here, but it's down to levels that are too low for many species to really thrive and proliferate. So that's really the what I have to say. I thought I'd end with a few words about what you can do to help. Buying my book may not help, but the last chapter of it does have my thoughts about how you can contribute to stopping this problem, not only just in the Delaware, but throughout the country. But if you're really more interested in just the Delaware River, I suggest you could contact the Delaware River Basin Commission. And Jerry's going to say a few more words about the DRBC. They're the organization that sets what happens with the environment in the Delaware River and Bay. And another organization to contact if you don't really want to talk to the people in charge is talk to people that are trying to push for change, and that includes the Delaware River Keeper Network, and they're advocating for changes in, for example, setting standards for the amount of ammonia that's released by these treatment plants. So with that, I'm going to hand it over to Jerry, and I look forward to hearing your questions after Jerry gets done talking. Thank you.
Okay, yeah, thank you, David. I'm going to bring my slides up, and I'm happy to be working with David. I've gotten to know David over the last year or so. David's a world-class scientist. I do recommend you buy David's book or acquire it and read it because it really explains the science in a way that I more fully understood. I thought I knew a lot about nitrogen and dissolved oxygen, but read David's book about where nitrogen came into society, synthetic fertilizers, how that changed the way it feeds the world. It helps to feed the world, but we deal with the runoff that's contributing to the dead zones. And I just wanted to say, as I bring my slides up, just walking in the footsteps here at the university of the world-class scientists that we do have that have studied the Delaware, like Jonathan Sharp and George Luther, Bill Ullman, Tom Church, now Matt Oliver working, Dwayne Fox over at Delaware State University. We have a real cohort of world-class scientists that have contributed to a real better understanding of the Delaware. And I just consider myself fortunate to have a little part of trying to understand that. And here at the university, we're situated right on the banks of the Delaware Bay and right at the ocean in Lewis, and we're situated 10 miles away from the Delaware and Newark. So what better place to study an estuary like the Delaware? So Mark, I'm going to bring up the slides. Let's see here. And bring those up here. Okay. All righty. And I'll be quick tonight. I know today it's the first day of July. Yeah, I'm in the Biden School. Proud to be in the Joseph R. Biden School of Public Policy Administration, specialized in water science and policy, and it's a very good place to do that. Mentioned to David that as I advance the slides, I really enjoy the Ocean Current series. Always wanted to be a part of it, actually, and I consider it to be a real tradition of summer. When you go down to Lewis, hopefully next year we'll go down and see the seminar. You get a sunburn, and then you come and you learn something really nicely. I've been out to participate in Rocky Mountain Biological Laboratory out in Crested Butte up there, up in Gothic at 13,000 feet. I've participated at Woods Hole. I know, David, you've studied there and participated. And I put the Ocean Current series in that category as a real summer tradition. So looking at the Delaware, just going to dovetail what David's already mentioned. These enterprises rely on clean water from the Delaware. So the Guggenheim gets clean water from the Delaware in the Catskills. Yankee Stadium, the United States Navy at the Naval Yard in Philadelphia. All these enterprises rely on clean, abundant water from the Delaware River watershed. And the Delaware River Basin is a basin. It's 4 states. It's managed by the DRBC. It's managed just like our Constitution says our government. It's a shared federalist system of shared governance between the federal government and the states. That's what the DRBC does. It was formed in 1961 by JFK. So it's 60 years old. It's a 100-year compact. And it tries to manage the 4 states, and there's 24 counties and over 800 municipalities, and manage that basin as a unitary watershed. And not to mention you have 19 federal agencies. And what also is very good about the Delaware Basin Commission is that they can get the economics. They can raise revenues to help study that, and they can charge a use charge, and they do on water use allocations that can be plowed back into managing the water in this basin. User pays approach. I mean, that's being argued about right now under infrastructure in Congress. How do you pay? Well, the DRBC has a way to pay. They just use a user charge. So I live in Newark, Delaware, and I pay about $6 a year into the DRBC Water Use Fund, and I'm happy to do that. I can afford that, and that money of the 8 million people that live in the basin that drink the water, that money adds up at a very low cost per person. So again, the literature, I looked at, I think, 60 different scientific publications published by the University of Delaware scientists on the Delaware estuary. I have a few. Why did I get interested in the Delaware? I grew up in Pennsauken, New Jersey, 2 blocks from the Delaware over by the Betsy Ross Bridge. I grew up, started ice skating on the river when the Flyers were winning Stanley Cups, the last Stanley Cups. And in about late February would go through the ice on the Delaware there in Pennsauken Cove. And I'd pull my legs out, and my mom would say, "What happened?" I fell into the Delaware because my skates were covered with oil. So I knew how bad the Delaware was. I observed that. So when I started looking at this, how you look at water science and policy, I selected the Delaware because it's as my scientists and advisors in graduate school said, this is a great research tank to look at. It has everything. So the Delaware was Lenape-Hocking by the Lenape, the ancestral grounds. We don't talk enough about it. It is the Delaware now by the Lord Delaware, the first governor of Jamestown. But perhaps the more appropriate name is Lenape-Hocking, and we're actually publishing maps. Henry Hudson actually came up the bay and got stuck on the oyster shoals that David showed right off the coast of Cape May, and turned around and went up and discovered the Hudson, and history was never the same. What if Henry Hudson went up further up and discovered, that New York would have been the center? That might have been New Amsterdam, perhaps, not that city to the north that has the 26 world championships. There's an interesting history So we can look at the science, but also look at the records. William Penn, oysters too big. Were the oysters right off the Philadelphia then, when there was salt water coming down? Maybe. Ben Franklin, of course he was involved. He petitioned to remove the tanneries on Dock Street, at Dock Creek that flowed right down before it was covered over. And before he died, he left funds to establish the first municipal water system in the United States. Cholera. Well, we now know that came from drinking water straight from the Delaware and the Schuylkill. Wastewater sanitary engineering in 1885 did a sanitary survey. They just had privies. That means the waste went right through the hole in the floor at Girard Ave. Gloucester, the water was still clean enough. They were serving 10,000 planked shad dinners in 1886. Rochester, 1897. Philadelphia councilman, right, David, in the Inquirer, thought that the Schuylkill water took a glass of lemonade. Schuylkill was so dirty that people emerged from the bathtubs dirtier than when they went in. The pilots flying over. HMS Nelson docked at the Navy Yard at the end of the Second World War to be fixed, and the ship's officers had to be given extra allowances by the Admiralty because their brass was getting tarnished by hydrogen sulfide by standing on the deck. There is a scientist that called the Delaware River an outstanding example of a destruction of striped bass habitat and thought then that the striped bass was extirpated. And then 1961, it began to turn around when Governor Lawrence convinced the reluctant JFK to sign the DRBC compact. JFK didn't want to sign the compact because he didn't want to give up the federal power. He was advised by the Secretary of Interior at the time that you're giving up federal power. But the governors convinced JFK to sign it, and it was a really good move. And in 68, 7 years later, DRBC began, that was 5 years earlier than the Clean Water Act, 5 years before, issued waste load allocations to these wastewater plants that David mentioned, and the cleanup began. And even in the early 70s, before the Clean Water Act was written by the fisheries biologists, that gross pollution had extirpated the striped bass in the river. It was thought that the striped bass would never come back. Then Congress and George McGovern overrode Nixon's veto in 1972. Nixon never signed the Clean Water Act. It was passed by this fantastic majority, and then there was written again that the shad extinction was going to be a distinct possibility, and that was only 50 years ago. There's HMS Nelson. The hydrogen sulfide fumes would tarnish the brass. God forbid. And then that's how bad was the Delaware. That's how bad it was. And then these are the news clippings from the New York Times showing JFK with the governors signing this fantastic act that began the cleanup a full 60 years ago. And that moved through Congress in only 3 months. Think of that. So the water quality's improved over 60 years. It doesn't quite meet the official standard during the summer and 3.5 milligrams per liter. And as David showed, these excellent seasonal graphs, it doesn't even meet the 6.5 during what we thought were the cooler seasons during the spring and fall. And 2012, the Atlantic sturgeon is on the endangered species list, right? Those are the dinosaurs of the deep that have their primary spawning grounds in all places, right off the shores of Marcus Hook, in basically the most urban part of the watershed. This is where the sturgeon, Dwayne Fox, DSU, and others pinged these amazing fish. So with atmospheric warming and sea level rise that we're seeing over a foot at Lewis, for instance, there is the concern that increased salinity chemically will decrease DO saturation. So with rising seas, warming water, more nutrients dumped in, you have to add atmospheric warning and increased salt water to these likely problems. So the DRBC was convinced that what about now is the time to perhaps elevate that DO standard of 3.5 that stood since 1968 to perhaps 4 or even 5 or even 6 milligrams per liter. What would the economic benefits be? So that's what I chose to concentrate with my background in economics with the excellent ecological economists we have at the university, George Parsons and Lee Anderson. So this is that DO curve that David showed. That it's kind of like that geologic timeline that you can see in the Grand Canyon, where it was 0 when I was growing up in the 60s, 70s, and 80s. Went to Rutgers in the early 80s, and it's recovered. But you can see it still goes below 3.5 during the summer there at the USGS gauge at the Ben Franklin, and that's the problem. But what's the optimism? If the Delaware River could come back, why can't, for instance, the climate come back? That for me gives me sustenance and a sense of optimism, because I've lived it and many others have as well. I know Jonathan mentioned he observed that the air got cleaner over his lifetime, and he wrote a piece about the optimism that we might be looking forward. So this is the way the DRBC manages it. It's an excellent way to manage the estuary. They set zones. So set up at Trenton, the DO standard is less, it's less stringent. But as you get into that dead zone, Camden, Philly, zones 3, 4, 5, the water quality standards are more stringent. It's 3.5 and 6.5 during the fall. And then the DO standard gets higher as you get into the flushed water of the Delaware Bay. So we know that the Delaware Bay turns over about once every 28 days, half from the fresh water coming down the Delaware from the Schuylkill, for instance, and then half of the flushing action of the 17-mile wide bay when you take the ferry across. And then, of course, all the tributaries, many of them are impaired, and they dump the nitrogen in as well. But the good news is shad's been coming back, although it's gotten less. The blue crawl crab landings have increased. That's a $7 million fishery. The largest, most lucrative shellfish fishery that we do have in Delaware is blue crab. And then the recreational striped bass. So that it's been written by Des Kahn and others that as the striped bass come back, perhaps that's why the shad are getting lower, because the striped bass are eating the shad. That's that relationship. Still to be maybe studied more, but that seems to be what's going on as the water quality. And then there's the excellent study in 1996 that showed with the DO getting higher, that catch per haul of 3 main species, the shad, the stripers, and the perch, were actually correlated with the improvements in DO. And that's an excellent piece. I've extrapolated this information over the last 25 years to prove that with higher DO, you'll see more fish catch. So the first economists at Harvard, when the economists at Harvard up in Cambridge got together with the engineers back in the 60s. Imagine that. The economists working with the engineers up in Cambridge. Well, they did. And they did the first economic study nationwide, actually, focusing on the Delaware. And they actually estimated, if you back then, this was 1966, that if the DO improved, you would have to spend this much, $200, $300 million, 150 to get to 3 from 0, 300 million to get to 4. So the DRBC looked at this in 67 and 68, and then the DRBC also looked at these benefits curves, right? The benefits exceeds the cost. It's worth doing, and you can see the net benefits. That's benefits minus costs. That's what the definition is. There seems to be a break point where you get the highest net benefits around 3, and then it would get down to 0 around 4. That's why the DRBC set the standard at 3.5. It was a compromise between the industrialists that wanted the 3 and the nascent conservation movement, the forerunners of the Delaware Riverkeeper, for instance, that wanted the 4. The commissioners did a strict compromise of 3.5, and that's where it stood over the last six decades, 70 years. So I did an economic study in my office with the assistance of our scientists and students at the behest of the Delaware Estuary Program that estimated the existing economic value. If you didn't improve the quality, it stands at $22 billion from all the benefits. That's water quality, recreation, fisheries. You can look at the habitats, like wetlands that rim the bay, the forests that are up in the upper estuary that cleanse the water, that worth about $21 billion. So if you were to build a water treatment plant or a wastewater plant to replace the ecosystem goods and services that the Delaware River Basin provides naturally, you'd have to build a $21 billion wastewater plant. That's essentially what that means. And then also it's a jobs engine. There's over 600,000 jobs that drive about $10 billion in wages. So that's caught the interest of our congressional delegation. Remember, we have 8 US senators that represent the 4 states. And one of the last acts of Barack Obama before he left office signed the Delaware-based Conservation Act through the United States Fish and Wildlife Service. Now we have an appropriation of about $10 million that invests, that can boost not just the economy, but the environment as well, equally important. So any governor, and there are 4 governors, there are 4 commissioners along with the President of the United States that are the commissioners in the DRBC, would want an industry. So if an industry came in like an Apple or an Amazon came in, we want to build in the Delaware, in your state, we have that. We have an economic driver called the Delaware River and its estuaries. So commercial fish landings, for instance, if the water quality improved, would be about $34 million, we've estimated, at about $6 a pound. Paddling, that's an underestimated. If the water quality improved, you would have the paddling jobs provided. And during the pandemic, the Outdoor Industry Association has estimated that the economic value of recreation, paddling, et cetera, exceeds the energy sector, oil and gas. Outdoor recreation that depends on clean water far exceeds those big energy Goliaths that we thought were big. That's based on, that depends on clean water. Then fishing, hunting, and bird watching, hundreds of millions of dollars. Bird watching, wildlife watching is a $500 million industry and getting bigger because of the cleaner water is bringing back the, the bald eagles, which are fish-eating species. There are more bald eagles than there have been in 100 years in the Delaware River because the water is getting cleaner and the fish are here. And of course, America's founding fish, John McPhee, Pulitzer Prize winning author up at Princeton, wrote the book about it, and about the shad saving George Washington at the Valley Forge. The shad are coming back as well, although not in bigger numbers that we'd like. So ecosystem services, that's wetlands, farms, and forests. That's that $22 billion flora and fauna factory that we have. And these are the types of jobs that are provided. The ports, for instance. So where's the nitrogen coming from? I remember the ammonia, NH3 that David mentioned is the form that we're concerned with. That gets converted to nitrate with dissolved oxygen. That's what a wastewater plant basically does. But basically about almost half comes from the wastewater plants. This is from a GS model that I like to use. About 1/3 comes from agriculture. That's the fertilizer, that synthetic fertilizer, or even the manure that comes down. And we're all concerned about the air, the NOx, nitrous oxide, which is about 12% when we last looked at it. And surprisingly, only about maybe 1/8 comes from the urban and suburban. So we would invest a lot in these retrofits of these stormwater ponds, but it seems to be that it's good to invest in the wastewater in the agriculture. That's where the savings comes in. You get the most bang for your buck. Good news is NOx is down because of the pandemic, and hopefully with electric vehicles, that contribution will be hopefully driven down to a very small part of the pie chart. So nitrogen, we have some of the highest nitrogen loads from fields in the East Coast. The Delaware and the Chesapeake are 1 and 2 in the Eastern United States in terms of nitrogen load, in terms of delivered yield. We have a lot of nitrogen coming down. A lot of it's coming from the Brandywine and White Clay, just over the line there into Delaware. So you do a marginal abatement cost curve. This is what economists, it's the low-hanging fruit. You can remove about 90% of the nitrogen for about 30% of the cost. And so if you invest about $300 million a year, that sounds like a lot, but 15 million people drink the water from the Delaware. So it's really not a lot of money at all, actually. And if you did that, you can really clean up the Delaware. That's the thought process. and then spend less on the others, the atmospheric and the urban suburban. You can really drive that down by spending on these two. And that's what the DRBC is doing. So looking at the benefits, you can look at the use. That's where you could put a dollar value on it. We could put a dollar value on how much a kayak costs, for instance. We have that information, or how much you spend to go stay in a hotel to go bird watching. And then non-use values, which is what are you willing to pay for clean water? That became recognized after the Exxon Valdez disaster, when Exxon was demanded to pay by the Attorney General of the United States. What would the population of the United States be willing to pay to know that there's clean water off the coast of Alaska? So that became accepted. And so if you look at those two, you could start looking at what are the benefits if you improve the quality of the water from 3.5 to 5. So that's what my office did. And you basically ask yourself, you went from boatable, cleaning up the boat, but you don't want to fish in it, cleaning up the fish. The Delaware is right around here, almost fishable. I'd give it a B-. And the cleanest water is swimmable. And there's a big effort going on at Penn Water Center to say, what if the water quality standards went all the way to swimmable off the city of Philadelphia? That's achievable. You can do that. And the short of it is, you could estimate that the existing value of the Delaware in billions from these uses right now is about $2 to $3.5 billion. That's the use value of the water. That's not the total that I mentioned, the 22 billion. This is just directly related to the Delaware River. If you improve the quality of the water by DO from 3.5 to 5, 5 seems achievable. Your max is 7.5, only because at 30 degrees C, which the water can get to during the summer, I think it is right now at that 100 degrees on I-95, you can only get to 7.5 because of DO saturation. Because water DO is inversely proportional to the temperature of the water, as David mentioned. You could reap benefits of $500 to $1.2 billion to society. And as we just saw, the costs may be a few hundred million, but the benefits far exceed that. So any industry would, even the Corps of Engineers would say, if you had a benefit cost ratio of far greater than 1, it's worth investing in. And that's what I subscribe to, and I think others are seeing as well. And so the Congress has said that. Now we have an appropriation that helps us to offset that. And so here I couldn't resist a supply and demand or a benefits cost curve. If you took the benefits here, the downward sloping marginal benefits, that's the difference in the cost. The intersection says, this is the strict card carrying economist, and I'm not, would say, you should set the standard around 5, because that's where the equilibrium point is. 4.5 to 5 would be that. That's purely economic. A fisheries biologist would say you need 5 to 5.5 to 6, because the Atlantic sturgeon, as David mentioned, during those fragile times in the spring and fall, when the adults swim back down to the ocean, they need the higher DO. So perhaps the DO should be set higher. That's what the debate's going on right now in the DRBC. So how to fix it? We have nature-based solutions. Like the New York City, they could have built a $10 billion water filtration plant upstate New York in Yonkers, right there in the Bronx, right up the Bronx. They convinced the EPA to say, why don't we work with the farmers and plant more forest around the 3 Catskill reservoirs? And they spent about $1.5 to $2 billion to date. Far less than $10 billion would have been to build the engineer solution. In the Chesapeake, wastewater would be cost about $9 a pound per nitrogen. We could use a currency. Forested buffers only cost $3. As a matter of fact, cover crops and no-till farming only costs about $1 per pound. And that's being done here in Delaware to great effect, and in the Chesapeake and up in Pennsylvania. And then a conventional wastewater plant, I kind of mentioned that the ecosystem services value of a conventional wastewater plant is far less to have those excellent saltwater wetlands that we have that rim the Delaware Bay along Route 9. They are priceless. So that is kind of the history of the governance and economics. about that. And again, this is one of a good one. This is not a Photoshop photograph of a striper, right? Down there at the Schuylkill River in downtown Philly. These are the type of fish that we're seeing in the Delaware, the improved DO that David has written about in his book, and it's really happening. And so I'm excited about the future. To me, the limiting factor is the economics. We need the money to do it right. Come on.
Thank you both, Dr. Kauffman, Dr. Kirchman. Appreciate your presentations. We had a lot of good questions starting to come in, and some comments, some conversations happening alongside. But I know we all appreciate hearing from you both on this topic. As I mentioned at the beginning, I'm going to go through the questions we have in the Q&A and pose them to Dr. Kirchman, Dr. Kauffman. I will do my best to guess who might be best for each, or maybe you can both take a crack at some of them. But I'm noticing with a couple here, I think might help if I can ask a question first, set up a couple of these other ones. You guys have mentioned that, carbon, ammonia, nitrogen, these are the things feeding these dead zones. And Dr. Kirchman got into it just a little bit, but can you kind of give us a broad strokes of the mechanism? What is it about these nutrients that's causing the dissolved oxygen to go down, so we can understand then why the changes are necessary to make an improvement?
Jerry, you want me to? I guess
Yeah.
I'll tackle.
I'm going through the balancing the chemical equation now, Dave, but I think that's your best bet.
Yeah. So, basically in all these dead zones, it's a problem of the oxygen being used up faster than it's being supplied by diffusion, by photosynthesis. So in the Gulf of Mexico or in the Chesapeake Bay, what's happening is that these excess nutrients are coming into both the aquatic habitats, and they're fueling these algal blooms. Too much algae. And these algae, while they make oxygen at the surface, they eventually die and sink to the bottom. And that's where the bacteria go to work and degrade that organic material and use up the oxygen. Back in the dead zone days of the Delaware, it wasn't nutrients, it was just raw sewage coming in. And instead of algae, it was human feces and other organic material that was used by these bacteria that sucked up all the oxygen as they degraded it. So that's in a nutshell the problem that all these places face is excess oxygen use by the bacteria compared to the diffusion of oxygen from the atmosphere and the synthesis of the oxygen by algae at the surface. I mentioned the river right now and a couple other places around the world has this problem of ammonia. That's a little bit different problem where, again, as I try to say, comparing ammonia to a Big Mac, maybe a donut would be a better comparison. These organisms are using that as an energy source and they're oxidizing, they're degrading it. And in the process, they use up oxygen. A little bit different, but same problem. Too much oxygen use, not enough oxygen supply.
Yeah, I appreciate that kind of backing up a step for me and maybe some of the others in the audience. Had a question that's kind of maybe related. You mentioned algal blooms. Nancy Kastner asks, is a red tide a result of a dead zone? Or I guess, what's the interplay between something really recognizable, like a harmful algal bloom, like a red tide, and a dead zone?
It's easy to talk about the red tides and all algal blooms, as I just mentioned, fueling oxygen use in dead zone formation. So that's really clear cut. So again, these algae just go wild. In a red tide case, they are types of dinoflagellates that color the water red. But other cases where they're just other types of algae. And again, when they die, they sink to the bottom. The reverse, having a dead zone cause a red tide or more generally an algal bloom, that's a little bit harder. There are some studies showing that it occurs in the Baltic Sea, where when oxygen disappears, another nutrient is released from the sediment, that is phosphorus. And that can fuel an algal bloom in the surface waters. So it's really clear cut. Algal blooms cause dead zones, not quite as clear cut that dead zones cause algal blooms.
That's interesting. I appreciate that. So it's both. Definitely a cause, maybe a result in some cases. Dr. Kauffman, I want to put one to you here. Now that we have a little bit of a picture of how this is happening. We had a question come in from Lori asking, how concerned should we be with the substantial influx of additional people and building in Delaware, or presumably throughout the watershed? Is there environmental policy in the pipeline that would curb the impact of more pollution into the river because of a population surge? She says she's wondering specifically about the impact of lawn fertilizer and leachate from landfills. So that was actually maybe about 3 questions for you.
No, it is concerned. Well, Delaware's a nice place to live. Everybody wants to live by the water. It is a nice place to live. It's a beautiful place to live, and everybody wants to move to Delaware. I see that, and I just wanted to say hi to Nancy Target. I just saw Nancy was on, and our first woman president of the University of Delaware, and the long-term dean of the College of Earth, Ocean. Hi, Nancy. I just remember brown algae was one of your talks, and I just wanted to say hi. But yeah, so we're about almost 1 million people here in Delaware, and we are a coastal state. So under Sea Grant, all 3 counties in Delaware are actually coastal, which is very interesting to know when I talk to our scientists at Sea Grant. And about 1 million people and growing. I think Sussex County is one of the fastest growing counties in the United States based on the last census. And so talking about lawn fertilizer, what I say is, and recommend when asked is not to fertilize during the summer. To do it when it's cooler, when the water, because the water's cooler then, can absorb more oxygen. So in the Barnegat, for instance, which is another national estuary, there's actually a law, not a county code. You can't fertilize, and that actually can really help. And with that, you can have a healthier lawn that actually can absorb more carbon. Our scientists at the University of Delaware found. So landfills have become less of an issue because of the legacy landfills prior to the 70s are being fixed as Superfund sites up here in Newcastle County. But the standards, the triple lining of them is a real good protective thing. I'm more concerned about the impervious cover that we see, say, with more neighborhoods. But there are good, easy fixes: narrower streets, one sidewalk on the side of it. And so I think with proper planning that we can address the more people issue that we might have. But what people can do when they move here is to be very progressive in terms of encouraging their elected officials to care for clean water, and we're seeing that. I think we have an informed electorate in the state of Delaware with the people that are moving in.
I think there was some news out of the session that just ended. I haven't finished reading. That was just yesterday or early this morning, maybe. But I think there was some clean water funding passed in the General Assembly, and things underway in Delaware.
Yeah, House Bill 200. That's a $50 million that were allocated toward clean water and flooding. That is huge.
Like you said, there's solutions, but they need the investments behind them. Got a couple questions from an alum, Sam Hellings. I think these are probably good for Dr. Kirchman, kind of on the technical side for measurement here. I'm just going to read both of them because I think they're related. He says, how's the technology to measure oxygen developed over time? Are the measurements from 160 years ago comparable to measurements from today? Can we look at those charts you were showing and trust, the numbers all the way back? And then he's wondering whether there's a standard depth at which oxygen is measured, remembering that the depth, thinking he remembers that the depth may influence the oxygen, or the temperature related to the depths is going to influence the oxygen. So are the measurements comparable?
I'll address the second question first. That's the easier to choose, because I don't know if there is a standard. I'm sure there is, but I don't know off the top of my head. It's generally thought not to be an issue in the river, especially because, as I mentioned, it's fairly well mixed. I have to say that even though it's well mixed, back in World War II era, it wasn't enough to stop oxygen being depleted, just because there's so much organic material that was being released due to the untreated sewage. So it's not, I'm sure there's a depth that they always measure at, but it's not so critical for the river. Even in the bay is fairly well mixed, and we do see some stratification is the technical term, light, warm, less salty water on top of denser, colder, more salty water at the bottom. But it's not quite the issue as say in the Chesapeake Bay. The second question was about changes in technology. That's always an issue when you talk about these long time series, and scientists are very, very careful as much as they can be to make sure that when the technology changes, that the measurements can be compared. Fortunately, the Ludwig Winkler came up with his method for measuring oxygen back in, I can't remember exactly the date, but sometime in the 1880s. And that's basically been the gold standard ever since. Now, there were some measurements of oxygen by really laborious ways. Before then, on the HMS Challenger expedition, if anyone who knows about their naval history may know that ship. That was done by a different method. So, that's a little bit less clear. Since then, even though the Winkler method is still the standard, there have been tons of other methods that are much easier to use. They can be automated. They can be deployed from, I was about to say drones, but I guess drones are in the air, not automated submerged vehicles, AUVs, that Matt Oliver uses. Buoys, all these other ways of measuring oxygen, but they can all be compared. And I think there's less of an issue as we get into the late 20th century with these changes, because it's always compared to, say, the Winkler method.
Thank you. One of the things I love about ocean currents is the kind of range of attendees and questions we get. They go from very general to very scientific and specific, people who have background. And one of the things we were excited about tonight is now we've got the opportunity to talk both the science and policy, and I think that has kind of worked for us. Looking at I know we're already over time a little bit. This has been a compelling evening, and I don't want to go too late, but I also don't want to cut off conversation too early if I don't have to. So a question here, that's kind of specific thing, further down the watershed. Someone's asking about if anyone is testing, I don't know whether either of you guys are going to know this, but anyone testing the Gordon's Pond area, wondering if there are any issues in that region with wastewater that needs further treatment or known problems down around that area.
I know exactly what the smell the person's talking to. It can stink. It's not due to raw sewage, that's for sure. It's due to these algae that are growing in Gordon's Pond and are dying along its shore, and that's what we're smelling. Sometimes you can get quite excessive growth of algae of various types in that pond. It's not due to, I don't think it's due to the treatment plants directly. Maybe it's some of the nutrients coming from the plants, but other sources of nutrients. Mm. So I don't think we have to worry about untreated sewage. There was a problem with the Lewis treatment plant, when was it? About a year ago, maybe someone else remembers when we had that problem. But even then, it was very short-lived. But the problem that folks experience at Gordon's Pond is due to the dying algae there. And that's what we're smelling.
Thank you. Yeah, I think that's definitely what they were referring to. I think maybe we'll do one more, and I apologize to anyone we haven't been able to get to because there are quite a few. But I think maybe one more question here for Dr. Kauffman is sort of in your wheelhouse. Michael asks, in the case of migratory species like striped bass, and of course, talking with you, I think shad, is there any evidence of their migration patterns changing as they react to the local dissolved oxygen levels? I think, Dr. Kirchman mentioned a barrier effect. Is there that or other effects about which creeks they may use, things of that sort?
Yeah, so we do know scientifically, and also, just observing that the American shad, that when that dissolved oxygen block was removed, They can swim all the way up to the Catskills. The U.S. Fish and Wildlife Service does scene surveys up there at the Delaware Water Gap. The Lewis Fishery does a survey right there at the Lambertville. I saw someone mention the Lambertville Shad Fest, which is really great to go to there at New Hope. And also, I observed them myself. Actually, I went on a kayak expedition in Delaware Water Gap 2011 and saw these aquamarine objects floating in floating circuit. I thought they were toy boats, to tell you the truth, radio toy boats. They were shad, American shad, that were full 200 miles upstream from the bay. So that the migration patterns have changed and they have come back. We actually see this in the Brandywine, which is the third largest freshwater tributary to the Delaware Estuary, surprisingly enough. Last summer, Dr. Ed Hale from Delaware Sea Grant found juvenile shad, about 60 to 70 right there underneath I-95 after the city of Wilmington removed the first dam there at Market Street. That was a 300-year-old dam and its footprint. That means that if you remove the dams, which are in their way, and the quality of the water improves, that the shad will come back and they'll spawn. And they'll do it less than a year after the dam is removed, which is fantastic.
Great. Well, I want to thank you both again. It is belatedly occurring to me that folks might like a link or two. So I'm going to stall and look for that because there is a lot of good information in Dr. Kirchman's book on this topic. And, I encourage everybody to take a look at that. I have to admit, I have not yet finished it, but I have started it and looking forward to reading the rest of it. So I'm going to drop that in the chat for everybody. And once again, anybody whose questions we didn't get to, sorry for that, but we do have a little bit of a time limit to keep an eye on. Hope you will all join us in 2 weeks when we have the next installment of Ocean Currents. And you will be getting, as everybody here obviously registered for tonight, you'll be getting emails Monday thanking you for coming in with information about how to add to your registrations if you haven't already. So thank you both. And thanks to everyone who's joined us. Have a good evening.